Welcome to Back to Basics. Let's look back at electrical circuit diagrams and how to solve problems using circuit diagrams. When solving circuit diagrams, fill in all the given information on the circuit diagram. If no diagrams provided, draw your own diagram from the word problem. Remember that questions always follow a logical progression. The answer to question A is needed to do question B, so do question A first. Always make sure that you use the quantities that are relevant to a specific part of the circuit. Use color to show a series versus parallel. Let's look at a simple circuit. In the circuit, the 9-volt battery and the ammeter have negligible resistance. Voltmeter V has a very high resistance. If we look at the circuit, we have a series part of the circuit drawn in red. There is a parallel part to the circuit drawn in green. The potential difference across the cells is 9 volts. Let us now look at some questions based on this circuit. The first question asks, calculate the resistance of the external circuit. This means that we need to calculate the parallel resistance first and then add the parallel resistance to the series resistance to get the total resistance. The formula you need are on the formula sheets given in the examination. Using the equation for the parallel resistors, we substitute in the values, so 1 over 6 plus 1 over 3 is equal to 3 over 6. Remember to invert both sides of the equation. Therefore, the parallel resistance is equal to 2 ohms. Now we add the parallel resistance to the series resistance, and so 2 plus 1 is equal to 3 ohms total for the entire circuit. The next question asks to calculate the reading on the ammeter. The ammeter is in the series part of the circuit, so we're looking for the total current. Here we need the total potential difference given as 9 volts, and we worked out the total resistance as 3 ohms. Thus, using voltage is equal to current times resistance, we get 9 is equal to 3 times current, so current I is equal to 3 amps. The next question asks us to determine the reading on the voltmeter. The voltmeter is across the parallel part of the circuit. So we need the total current from the series part of the circuit and the parallel resistance to work out the voltmeter reading across the parallel part of the circuit. When writing the equation, it helps to use subscripts to show where in the circuit you're working. So, in this case, P for parallel and T for total. Therefore, using potential difference is equal to the current times the resistance, and we get 3 times 2, which is equal to 6 volts. The next question asks us to calculate the current through the 3 ohm resistor. Remembering the basics of circuits, current split proportionately in parallel, and that current takes the part of least resistance. Also, the resistors are in parallel and therefore equal. First, we need the voltmeter reading across the parallel resistors. This we calculated in the previous question. So we can then calculate the current through the 3 ohm resistor. Voltage equals current times voltage. 6 for the parallel voltage, and it's equal to the current which we are trying to calculate times the resistance of 3 ohms. This gives us an answer of 2 amps. Looking at the answer, we see that it's less than the total and bigger than what will be going through the 6 ohm resistor. Checking the answer, we can make an educated guess that the answer is in the correct range.